Hi everybody, today we're going to talk about reduction formulas for trig. A little bit different than most of the videos I do. I'm not going to actually solve any problems, I'm just going to show you how these formulas are derived. Reduction formulas for sine, cosine, and tangent let us rewrite even powers of the function in terms of the first power of the function. This can be really helpful when studying higher level mathematics like calculus. To start our derivation of the reduction formulas, we're going to take a look back at double angle formulas. I'm going to start with the cosine of 2 theta is 1 minus 2 sine squared theta. And the first thing I'm going to do is flip this equation. So I'm putting the 1 minus 2 sine squared theta on the left and the cosine of 2 theta on the right. From here, I want to solve for sine squared theta. So I first need to move the 1 over to the right side, which gives me negative 2 sine squared theta equals negative 1 plus cosine of 2 theta. I'm going to divide by negative 1 to make this positive. So I have negative 2 sine squared theta over negative 1 equals negative 1 over negative 1 plus cosine 2 theta over negative 1. And you can see I just flipped all the signs. I have 2 sine squared theta equals 1 minus cosine 2 theta. I could have divided everything by negative 2 to start, but I have a specific way I want my answer to look, which is why I take the extra step. From here, though, I will divide both sides by 2. This gives me sine squared theta is 1 minus cosine of 2 theta over 2. So what I did here is I reduced from power 2 on the left to power 1 on the right. This is that reduction part of our formula. We do have sine on the left, cosine on the right, but I think you're probably used to that by now that we flip back and forth from all of our trig functions. So we're going to do that a second time. This time we're going to use the double angle formula that cosine of 2 theta is 2 cosine squared theta minus 1. Just like last time, my first step is just going to be to flip this equation. This time, I want to solve for cosine squared theta. I'll move the 1 over. So I have 2 cosine squared theta equals 1 plus cosine of 2 theta. Then I divide by 2. This gives me cosine squared theta is 1 plus cosine of 2 theta over 2. Once again, I have a reduction of power. I have power 2 on the left, I have power 1 on the right. We have one more formula to look at. We would like to look at the tangent squared theta. We think of tangent as sine over cosine. So if we have tangent squared theta, then that would be sine squared theta over cosine squared theta. Well, we've already said that sine squared theta is 1 minus cosine of 2 theta over 2, and cosine squared theta is 1 plus cosine 2 theta over 2. We have a complex fraction, meaning a fraction within a fraction, so we're going to simplify that by dividing by the reciprocal of the denominator. When I look at 1 minus cosine 2 theta over 2 times 2 over 1 plus cosine of 2 theta, I can see that the 2's cancel, leaving me with 1 minus cosine 2 theta over 1 plus cosine 2 theta. So this is the last of our 3 reduction formulas. And again, what is it saying? It's saying go from power 2 down to power 1. There are other ways to write the reduction formula for tangent squared theta, but we'll get to those in the next video. Reduction formulas are important for the development of half-angle formulas, which we'll do in our next video.